On number 8, my first step is going to be to eliminate the 2x from the second equation, because I already have a single x in my first equation. So I want to take equation 2 plus negative 2 times equation 1. We'll get rid of that, and that'll be our new equation 2. So I'm going to take 2x plus 3y minus 4z is equal to negative 3, and negative 2x minus 4y plus 2z is equal to negative 2. And if I add these up, the x's go away, and I have negative 1y minus 2z is equal to negative 5. So all of my other equations are going to stay the same, except for equation 2. And that's going to become 3x plus 6y minus 3z is equal to 4. So third equation stays the same, first equation stays the same, second equation is the one that we want to update. So then if I take equation 3 plus negative 3 times equation 1, this is going to be my new equation 3. So this is going to be 3x plus 6y minus 3z is equal to 4, and negative 3x minus 6y plus 3z is equal to negative 3, which if we add these up, the x's go away, the y's go away, the z's go away, so I'm left with 0 is equal to, and then 4 plus negative 3 is 1. So if I update my system, because we're supposed to update the system, this is going to be x plus 2y minus z is equal to 1, negative 1y minus 2z is equal to negative 5, and then 0 is equal to 1. So because this is a false statement, that means that there is no solution. Graphically, systems of three equations, three variables are planes, meaning they're like sheets of paper, and no solution would mean that there is no three-dimensional point where all three planes intersect.